Hi, this is Dr. N.K. Ilangu, Professor, Department of Electrical and Electronics Engineering, K.S.Rangasamy College of Technology. From this video lecture, I would like to explain the concept per unit value. The content of today's video's lecture: per unit value, need of per unit system, and what are the advantages of per unit system in power system network. I will explain. The first one, per unit value. The basic definition of per unit value is the ratio of actual value by base value. The per unit value of any quantity is defined as the ratio of the actual value of the any quantity to the base value of the same quantity as decimal. From this basic definition, we will derive the equation for all the parameters of electrical power system network. Yes, the basic formula for per unit value, that is actual value by base value. From that we can develop the equation for per unit value of voltages, power, current, impedance and reactance. The first one, per unit value of voltage, that is equal to actual value of voltage in kilovolt by base value of voltage in kilovolt. Here we have to notify that very important cases. Numerator and denominator both should be in same unit. Suppose in numerator we are going to express the voltage in terms of kilovolt, means the denominator is also going to represent in kilovolt. In numerator kilovolt and the denominator it will be a voltage or megavolt, means we are not going to get the correct answer, right? This is the basic this is a very common mistakes done by most of the students. So you have to careful on the units prescribed in numerator and denominator. And the second one, per unit value of power, the actual value of power in MVA by base value of power in MVA. Both numerator and denominator same unit is going to be used for power value too. Then from this basic base values of voltage and power, remaining per unit quantity is going to be derived from that. That is per unit value of current, actual value of current in amps by base value of current in amps. Similarly, per unit value of impedance is equal to actual value of impedance by base value of impedance. And finally, per unit value of reactances, actual value of reactance by base value of reactances. So these are all the formula to calculate the per unit value of electrical quantities. Okay. See, normally we are going to take voltage and power are the base values, right? From these base values, we are going to derive the other quantities, right? Select two base quantities to define a given per unit system. Usually they are voltage and power, right? Normally voltage base values and power base values are going to be assumed. From that we are going to derive the remaining thing, right? For these cases, we are going to take it V base is equal to V rated and power S base is equal to S rated. Normally the rated voltage and power rating is available in all the electrical equipments, right? Specifications are mentioned in the electrical devices. From that we can notice what are the rated value of voltage and current, that is going to be taken as the base value, right? From this value we are going to derive the current base, Z base and reactance base and all, right? See, what is the formula for current base? From the Ohm's law, that is power by voltage, that gives the value current, right? Normally power is the product of voltage and current. Here the power means, here we are going to, I am mentioning that apparent power, it is not be the reactive power or real power or reactive power. So apparent power, that is the product of voltage and current. So from that I base is equal to S base by V base, we can calculate the I base. And Z base, again from the Ohm's law, V base by I base, or another name we derived from the cases V squared base by V squared base by S base. And the per unit value, we all know that the basic formula, per unit value, that is actual value by base value. So from that V per unit is equal to, what is this? V actual by V base. Similarly, current per unit value is equal to current actual by current base, and we know that power S base S per unit is equal to S actual by S base, right? From that we can develop the equation for per unit value of voltage, current and power, right? Here I am going to explain how we are going to change one per unit value into another per unit value, that is old one to new one. From each and every cases the base value is going to be changed over that. For that scenario we are also going to update the per unit value from old to new. What is the cases? From the simple equation we can develop it. Let Z is equal to actual impedance in ohms and ZB is going to be taken as the base impedance in ohm, and we know the basic formula for per unit value, that is equal to actual by base. So equation 1 represents what is this? Actual by base value, that gives the per unit impedance of the circuit element. Here we know what is the base value from that Ohm's law, that is equal to KVB squared by MVAB squared, and numerator Z will be there. So Z is equal Z by KV base by squared by MVA base. We obtained what is the per unit value of impedances. See that equation MVAB, that part MVAB is denominator of denominator, that is going to be represented as in numerator. So that is equal to Z into MVAB by KVB squared is the equation for calculating per unit impedance. Actually, the equation 1 shows that per unit impedance is directly proportional to the base megavolt ampere, right? See, Z is directly proportional to the base power and inversely proportional to this voltage square, right? Square of the base voltage. Using equation 1, we can derive an expression to convert per unit impedance expressed in one base value to another base value, that is old base to new one. How we are going to take it? Let KVB old and MVAB old represents old base values of voltages and current, and again KVB new and MVAB new is going to be taken as the new base values of voltage and power, right? Anything if you are going to derive, we are going to assume voltage and power base values are the basic one, right? Then LH Z per unit volt, ZPU volt is going to be represented as per unit impedance of the circuit element calculated on volt base, and ZPU new is going to be represented as per unit impedance of a circuit element calculated on new base. If old base value are used to compute the per unit impedance of a circuit element with impedance Z, then equation 1 can be written as what is this? Z per unit volt, that is we already derived in the previous slide. Z per unit volt is equal to what? Z into MVAB volt by KVB volt square. From that Z is equal to what? Just MVAB volt will be shifted to left hand side. So what is the equation? Z per unit volt into KVB volt square by MVAB volt, right? From the above equation we can rewrite the equation for impedances, that is actual value of impedance. If the new base values are used to compute the per unit impedance of a circuit element with impedance Z, then equation 1 can be rewritten as like this: Z per unit new is equal to what? Z into MVAB new by KVAB new. Here it is new, so numerator and the denominator both should be new, right? On substituting Z from equation 2 in equation 3, we can obtain the equation for Z per unit new, that is equal to what? Z per unit volt into KVB volt squared by MVAB volt and MVAB new by KVB new square. That is going to be write the equation like this, that is Z per unit new is equal to Z per unit volt into KVB volt by KVB new whole square into MVAB new by MVAB volt, right? The equation 4 is used to convert the per unit impedance expressed on one base value to another base value. Here, what is the need for the cases? The components or various sections of power system may operate at different voltages and power levels. Even even we know that our houses we are using three-phase supply and a single-phase supply. For three-phase supply, normally we use 400 volt is the rated voltages. For single-phase supply, 230 volt is the normal rated voltages. Here, even in our house we are using two different ratings of voltages. So, in order to make calculation, we are coming into common domain. It is called as base value. So, this is the need. It will be convenient for analysis in power system if the voltage, power, current and impedance ratings with the components of power system are expressed with the reference to a common value. It is called as base value. Right? Advantages: calculations are very easy. Per unit data representations yields valuable relative magnitude. Circuit analysis of system containing transformers of various transformation ratio is greatly simplified. And per unit systems are ideal for computerized analysis and simulations. Normally, yeah, this one root 3 and 3 are eliminated. Normally, the three-phase supplies are going to be represented as line quantity and phase quantities, and it will be multiplied with 3 for 3 number of circuits. So once if you are going to convert it into per unit values, these calculations are going to be simplified. Thank you.